So good morning all my dear students. We had completed with our second module, that is differential equations. So now I'll go with the next module, that is partial differential equations. So you have already studied what is partial differentiation in your first semester. So now in this module what you're gonna study is the next part of that, that is partial differential equations. And remember my dear students, this partial differential equation is very much useful in many of the applications when it comes to engineering problems or any of the real world problems. So this partial differential equation is very much important when you go for your higher semesters also. So now we'll go through the contents, like what and all you'll be studying in this partial differential equations. So first we'll be studying how to form a partial differential equation by eliminating an arbitrary constant and then arbitrary functions. Okay, arbitrary constant means in a equation they will be giving you some constants like c1, c2 or ab. We need to eliminate that. Or arbitrary functions means you'll be having some function of like f of x plus b, x plus y, or g of x plus y. We need to eliminate that function f, and we need to form a PDE. That is your first part. And second part is solution of non-homogeneous partial differential equations by direct integration method. Okay, so that method I'll explain once it comes, but you should be knowing what is a homogeneous and a non-homogeneous equations. Okay, and after that, solution of homogeneous partial differential equations which involves the derivatives with respect to one independent variables. Okay, so one is solution of non-homogeneous, solution of homogeneous. And next we have Lagrange's partial differential equations, and after that is application part, that is derivation of one dimensional heat and wave equations, derivation as well as solution of one dimensional heat and wave equations. Okay, so this is what you're going to study in this module 3, that is partial differential equations. So first I'll move on to the first topic, that is forming a partial differential equation by eliminating the arbitrary constant and arbitrary functions. Okay, so before going into the actual syllabus, I'll just go through some of the basic definitions which are required here. Okay, yes, so definitions. First definition, what is a partial differential equation? You know, many students, whenever I take class, I'll be asking with the basic things, what is a differential equation? If you know what is a differential equation, then I can tell you what is a partial differential equation. So what is a differential equation? A equation which involves variable as well as its derivative is known as a differential equation in a simple way, correct? Same way, what is a partial differential equation? So an equation which involves one or more partial derivative of a function of two or more variable is called as partial derivative. Okay, before that, I'll just tell you what is a partial differentiation. Suppose if you have z is equal to function of xy, correct? So then I can differentiate that z with respect to x or with respect to y. That type of terms are known as partial differentiations. Or if we have a function with more than one variable, then we always go for partial differentiation. So based on that definition, we are defining this partial differential equation now. So an equation which involves one or more partial derivative means it may be dou z by dou x, dou z by dou y of a function of two or more variables. Like if you have function of x, y, z and x, y, t, something like that, then it is called as partial differential equation. It's very simple. We should have a variable as well as a derivative. Okay. Next, a partial differential equation is said to be linear if it is of first degree in the independent variable and its partial derivative. Means if you have degree as 1, then it is independent, then it is said to be linear equation. If each term of partial differential equation contains either of the dependent variable or one or more partial derivative is said to be homogeneous PDE. See, I was telling about this, correct? You should be knowing what is homogeneous. So what does it tell? If each term of the PDE contains either the dependent variable or one of its partial derivative, then it is said to be homogeneous. Otherwise it is called as non-homogeneous. So let me give an example. Okay, dou square z by dou x square plus z equal to 0. What is this equation now? Is it a homogeneous equation or a non-homogeneous equation? Okay, I'll go through the definition again. If each term of a PDE contains either the dependent variable or one of its partial derivative, then the PDE is said to be homogeneous. Now according to that, which is this equation? It's a homogeneous equation. Why? Because it contains the dependent variable, that is x, dependent variable, that is z, and independent variables derivative. Independent variable is x because z is a function of x. So dou square z by dou x square plus z is equal to 0. This is a homogeneous partial differential equation. Now I have another equation here. Dou square z by dou x square is equal to x plus y. What happened here? We have it if it contains either dependent variable or one of its partial derivative. So what happened here? We have the independent variable also. X and y are independent variables. Z is dependent variable, correct? So just keep one thing in mind, my dear students. If the equation involves x and y, that is independent variables, then it is non-homogeneous PDE. So in the question they will never mention whether it is homogeneous or non-homogeneous. Okay, we have to identify. How to identify? It's very simple. If your equation involves x and y, then it is non-homogeneous. If your equation doesn't involve x and y independently, then it is homogeneous. That's it. Okay. Now I'll go with the, that is how to form a PDE by eliminating the arbitrary constant and arbitrary functions. I'll directly take a question and explain it. It will be easy. There are no certain steps here. It's just like we have to go on differentiating. That's it. Okay. So I am just telling you, given a relation of the form f of function of x, y, a, b equal to 0, where z is a function of x, y, a and b are arbitrary constants, then we need to eliminate the constant a and b to form a PDE. That's what I said you. So we need to eliminate the constants a and b here. How to eliminate? We'll check it. Okay. And one more thing. Suppose z is a function of two arbitrary functions, then we have to find the partial derivative up to second order and use the necessary partial derivative of second order to form a PDE by eliminating arbitrary functions. Okay. Don't worry. Once when it comes plain here, and I'll just take one note here because in the problems I'll be using this note. What I'm doing is dou z by dou x, I'm taking it as p, or we can take it as zx, the notation. It's not like it's always necessary to write as p or q, but it looks very simple. That's why I'm just writing it. Okay. And dou z by dou y, we are taking it as q. Dou square z by dou square z by dou x square, we are taking it as r. Dou square z by dou x dou y, or dou y dou x, is nothing but s. And dou square z by dou y square is t. Okay. So p, q, r, s, t. P is nothing but dou z by dou x, q is dou z by dou y, r is dou square z by dou x square, s is dou square z by dou x dou y or dou y dou x. Remember, my dear students, dou square z by dou x dou y is always same as dou square z by dou y dou x. Okay, don't get confused. Zxy is always equal to zyx. Okay, this we have studied in your first semester already. And t is dou square z by dou y square, or we call it as zyy. Just a notations, nothing to do here. Okay, if you use this, well and good. If not, I can keep it as it is. No one will ask you. Okay. So now I'll be going with the first problem. Form a differential equation by eliminating the arbitrary constants. So which are the constants here? A and b, right? So first what you do is you go on differentiating. So z is a function of x and y and constants a and b. Am I right? So I need to eliminate a and b. In order to eliminate that, first what you have to do is you have to differentiate z partially with respect to x. So I have written the question, z is equal to x plus a into y plus b. So first I will differentiate with respect to x and y. So when I differentiate with respect to x, I will get dou z by dou x, which is equal to, x is here. So differentiation of x is 1 into some constant is multiplied. What is that? Y plus b. So I am calling p is equal to y plus b. Okay. Now when I differentiate with respect to y, dou z by dou y, or its notation is q. So y is here. Differentiation of y is 1 and b is 0. So x plus a is a constant which is multiplied to y. So it is x plus a into 1. Okay. So we got the differentiations. Now how can I eliminate? See, eliminating means I need to remove that a and b, right? So now what I can do in my given equation is, in the place of y plus b, can't I write p, which is dou z by dou x? Yes. And in the place of x plus a, can't I write q, which is dou z by dou y? Yes. So did we eliminate the constants there? Yes. So just check my next step. Using 2 and 3 in 1, we obtain z is equal to pq. Am I right? So x plus a is nothing but q, and y plus b is nothing but p. So z is equal to pq, which is a partial differential equation. Is it so? Yes, because z is equal to, what is p? Dou z by dou x, and what is q? Dou z by dou y. So it involves variable and its partial derivative, so it's a partial differential equation. That's it. Okay, are you clear with this problem? It's very simple. My suggestion is you just go on differentiating and see whether we can eliminate a and b. That's it. So first I differentiated with respect to p, I got y plus b. I differentiated with respect to y, with respect to y I got x plus a. So I just substituted in the place of x plus a as q and in the place of y plus b as p. So z is equal to pq. That is my required PDE. That's it. Now I'll go for problem. 2z is equal to x square by a square plus y square by b square. Okay, what to do now? See, first you don't worry, you go on differentiating. Okay, first differentiate with respect to x and y. So when I differentiate with respect to x and y, what will I get? So if I differentiate this with respect to x, 2 into differentiation of z is dou z by dou x is equal to, with respect to x, or I am calling it as 2 into dou z by dou x as p, which is equal to differentiation of x square is 2x divided by a square plus differentiation of y square is 0, so plus 0. Clear? So I got 2p is equal to 2x divided by a square, or I'll simplify it, or I am substituting for constant because I know I need to know what is constant there, correct? Or a square is equal to what? 2x by 2p, 2 and 2 will get cancelled, I'll get x by p. Proper? Next I'll differentiate with respect to y. So 2 into dou z by dou y, differentiation of z is dou z by dou y, or I am calling it as 2 into q, dou z by dou y as q is equal to 2 into differentiation of y square is 2y divided by b square, or what will be b square is equal to, solve for b square, y by q. Proper? Now what to do? Substitute that here, keep it as it is, that is your final answer. If you are not able to simplify, you can keep it as it is, don't worry. Okay, so I have simplified it here. So 2z is equal to x square as it is. What is 1 by a square? If a square is x by p, what is 1 by a square? P by x. That's what I have written here. See, x square as it is, 1 by a square I have written it as p by x, plus y square as it is, 1 by b square is nothing but q by y. That's it. That is your final answer. Finished. Or we call it as, we can cancel one x and we can cancel one y and y. So that is your required PDE. So similarly, I'll go for the next problem. Z is equal to a into log of x square plus y square plus b, which is a constant here, a and b. So I need to eliminate the constants a and b. So what did I tell you? You have to just go on differentiating, that's it. See, when we differentiate, obviously this b will get eliminated directly. Is yes or no? Because b is a constant, it is not having any variable, so its differentiation will become 0 directly. So first I'll differentiate with respect to x. So when I do that, dou z by dou x, I'm calling it as p. A as it is, what is differentiation of log x? 1 by x. So 1 by x square plus a square, x square plus y square, sorry, into differentiation of x square is 2x. Done? Okay. Or I am simply writing it as p is equal to 2ax divided by x square plus y square. Is it okay? Done. Similarly, I need to differentiate with respect to y. So dou z by dou y, I am calling it as q. Q is equal to, again a as it is, differentiation of log is 1 by x square plus y square, and I need to differentiate y. So y square is 2y. Or I am calling it as q is equal to 2ay divided by x square plus y square. Okay, my dear students, now tell me what will you do? See, in the previous problems it was very easy for me to substitute. You know, I used to get the values of a, b and substitute it. But here, in both the cases, I have the constant a here, right? So what will you do? Will you substitute for a, will you simplify for a from this one and substitute it here? No. Then it will not become a PDE. I am telling you again and again. You should involve both p and q. So what I will do? See, somehow I need to eliminate this a. Am I right? Correct? So can't I use these two equations and can't I add or subtract or divide? So I'll tell you what I am doing. So I'll just divide 2 by 3. That's it. Finished. Is it okay? So when I divide 2 by 3, P by Q is equal to, here what will get cancelled? X square plus y square, x square plus y square will get cancelled. 2a and 2a will get cancelled, is equal to x by y. That is your required PDE. That's it, finished. See, it's not like always we have to solve for a and we have to substitute it here. No. Whether you will add, whether you subtract, do whatever you want, somehow you eliminate a, that eliminate the constant. That's it. Okay. So here what did I do? The easiest way to solve this problem was to divide. So I divided P by Q. So 2a got cancelled, x square plus y square got cancelled, so x by y will remain. Or I can write it as Py, I'll cross multiply, Py minus Qx is equal to 0. That is my required PDE. Finished. Okay. So it is very easy. It's not like always we have to substitute the value of a and b here. No. The rule is here to eliminate the constant. That's it. Whether you divide, whether you subtract, no one will ask you. Somehow you have to eliminate it. That's it. Okay. So now I'll go for the next problem. Yeah, one of the interesting and application oriented problem I have taken over here. Find the PDE of the family of all spheres whose center lies on the z plane or center lies on the plane z equal to 0. What does it indicate? I am telling you an important point, my dear students. Just listen carefully. Center lies on z equal to 0 means what? Center lies on xy plane. So center will be on xy plane, z axis will be 0, which is having a constant radius. So what is the equation of a sphere? That is the first thing we should know here, correct? So see here, the coordinate of the center of the sphere can be taken as a comma b comma 0, correct? Why? Because z is equal to 0 means its coordinate axis is 0, right? So my equation of the sphere will be x square by a square, x square minus x minus a the whole square plus y minus b the whole square plus z minus 0 the whole square is equal to r square. See, equation of circle is what? X square plus y square equal to r square, provided the center is 0 comma 0, right? What is equation of sphere then? See, when circle is only x and y axis, sphere means it should be x, y and z axis, correct? Ball. So it will be x square plus y square plus z square is equal to r square. That is equation of sphere. But here what they are telling is, this sphere lies on the plane z equal to 0 means only the z coordinate is 0 but other two coordinates will be as it is. So we have to take it as x minus a the whole square plus y minus b the whole square plus z square or z minus 0 the whole square is equal to r square. Okay. Now what I have to eliminate? A and b. How to eliminate? Go on differentiating. So first I'll differentiate partially with respect to x. So when I differentiate with respect to x, what will I get? Differentiation of, take this entire term as x, differentiation of x square is 2x. So 2 into x minus a plus, is there any x involved here? No, 0, plus z square. Be careful when you differentiate z square, always keep one thing in mind, z is a function of xy. So differentiation of z square is 2z into dou z by dou x. That dou z by dou x we are calling it as p. I hope you can follow it. Make sure you write it and practice it. Here few steps have skipped directly. So dou z by dou x we are calling it as p. And when I differentiate partially with respect to y, what will I get? There is no y term in the first term, so 0 plus 2 into y minus b differentiation plus differentiation of z square is 2z into dou z by dou y when I differentiate with respect to y, but dou z by dou y is q equal to differentiation of r square, which is a constant, that is equal to 0. That's it. Okay. Now how to eliminate a and b? That is my question. So what we can do, if you check properly from this equation, if you want you can solve for x minus a and you can substitute it here, and you can solve for y minus b from this equation and you can substitute it here, correct? So but again I simplified these equations. I just divided by 2 and as I said, I solved for x minus a here and I solved for y minus b. So what I'll do, I'll just substitute these two equations here and write the final answer. Done. So what will be my final answer? Here in the place of x minus a, I have taken minus zp the whole square. In the place of y minus b, I have taken minus zq the whole square plus z square is equal to r square. Minus 1 the whole square is plus 1, forget about that. So minus z square, if you check, it is common in all the three terms. Sorry, z square, I have taken z square outside, so what is remaining? P square plus q square plus, I have taken z square outside, plus 1 is equal to r square is your required PDE. See, even if you stop here also, no problem. They will never ask you to simplify. I am telling you again and again, my dear students, it is not like always the final answer should be the same. Even if you keep here only as it is only, no problem. Okay, next problem. Z is equal to xy plus y into root of x square minus a square plus b. So my question, can we eliminate one constant directly with the differentiation? Yes. Which one? B. Because b is not having any variable, I can eliminate b directly. So I'll differentiate one with respect to x and y first. So when I do with respect to x, what will I get? Dou z by dou x, which is equal to p, is equal to differentiation of xy is y, because with respect to x I am doing, plus y is a term which is multiplied, I am keeping it as it is, into what is differentiation of root x? 1 by 2 root x square minus a square into differentiation of this x square is 2x. Cancel 2 and 2 here, or I'll get it as p is equal to y plus y into x is xy divided by root of x square minus a square. Clear? Okay. Next I'll differentiate with respect to q, y. So dou z by dou y, or that is equal to q, is equal to differentiation of xy is x plus y is here, differentiation of y is 1, but some constant is multiplied, you write that constant as it is, that is root of x square minus a square. Clear? So I'll get p is equal to y plus xy divided by root of x square plus y square, and I'll get q is equal to x plus root of x square minus y square, a square. Now what to do? How will you eliminate a? Can't you do, can you do anything with this 2 and second and third equation? Yes, what you can do? You can solve for this root of x square minus a square from this equation, and you can just substitute here. Am I right? So we'll see what we can do. See here. So I am solving for root of x square minus a square. I'll just take this plus x to other side. So q minus x is equal to root of x square minus a square. And this, what I'll do, I'll substitute it here in equation 2. Okay, so equation 2 is p is equal to y plus xy as it is divided by, in the place of root of x square minus a square, I am taking what? Q minus x. That's it. If you want to simplify, you or else you keep it as it is, but nothing will happen. Here I have tried to simplify it. See here, see my simplification steps. See, I am telling you again and again, if you stop here also, no problem, is a required PDE. No one will ask you. But I have shown you the simplification steps. Those who are interested, you can simplify, or else you can keep it as it is. I have taken y to other side, it will become p minus y is equal to xy by q minus x. Then I have taken this q minus x to other side, p minus 1 y into q minus x is equal to xy, or that is simply multiply term wise. I'll get pq is equal to xp plus yq is the required PDE. That's it. Okay. So my suggestion is you can stop here and you can keep it as it is. No one will ask you. Are you clear with the differentiations? Okay. So you don't worry. Go on differentiating with respect to x and y. See how we can eliminate the constant. Okay. One more important problem over here. Z is equal to a into log of b into y minus 1 divided by 1 minus x. So my dear students, before differentiating this directly, what you do is you try to simplify this. Okay, simplify in the sense you have some properties of log. What are those? I have written here. Log of a into b is nothing but log a plus log b. Am I right? Log of a to the power b is nothing but b into log a. And log of a divided by a divided by b is nothing but log a minus log b. So first, which property can I apply over here? I can apply fourth property of log, that is log of a divided by b. Sorry, third property. So log of, take this entire term of numerator as a and 1 minus x as b. So I'll be getting log a minus log b. Okay, that is this entire term, and numerator is b into y minus 1. So there I can apply my first property log ab. So log a plus log b. Hope you can follow it. Minus log of 1 minus x. Okay, try to apply the properties of log. Now we can go on differentiating. So first I will go for dou z by dou x, that is nothing but p. So a is a constant which is multiplied here, I have kept as it is. Log b, there is no any variable, so 0. Log of y minus 1, there is no x here, so 0. Minus differentiation of log x is 1 by x, so 1 by 1 minus x, and differentiation of 1 minus x is 0 minus 1. Proper? Okay. Now I'll differentiate, or I'll write p is equal to a into minus is plus, so a into 1 by 1 minus x. Or I'll solve for a is equal to p into 1 minus x. Now I'll differentiate with respect to y, so dou z by dou y. A again is a constant, there is no y here, so 0. Differentiation of log y is 1 by y minus 1, and differentiation of y is 1, minus log of 1 minus x is 0 because there is no y there. So solve for a again. So a is equal to q into y minus 1. So both the equations are equated to a, so I can write it as p into 1 minus x is equal to q into y minus 1. See, it's better if you stop here, or if you want you can simplify. So I have just taken this to other side and I have equated to 0 is my required PDE. That's it. Okay. So the problems are very simple, but you should understand the concept. Concept is you have to just remove the constants a and b. That's it. Okay. Okay. Now see the problem over here. So in all my previous problems, I had what? Constants a and b. But now what I have function z is equal to function of x square plus y square. See, that function may be anything. Now my aim is to eliminate this f. Okay. So that is nothing but elimination of arbitrary functions. So I said you there are two types. One is eliminating the arbitrary constant. Till now whatever you saw, it was eliminating the arbitrary constant. Now whatever you are seeing, it is eliminating the arbitrary function. Okay. So procedure is same. I am telling you again and again, go on differentiating. But here you remember one thing. Suppose if you have two functions, no, always we normally get two differentiations. I mean second order differentiation is required. Okay. So but here it is only one f. So one function we can go for only once differentiation. So I'll differentiate one with respect to x and y. So when I do differentiate with respect to x, dou z by dou x which is equal to p. So differentiation of that function is f dash. See, for example, if you have sine of x square plus y square, what will you do? Want to differentiate that sine first? Sine you will write it as cos, correct? Same way here, that instead of sine they have given you f. Okay. So differentiation of f is f dash of x square plus y square into differentiation of x square is 2x. Proper? Then dou z by dou y which is equal to q, the notation. See, even if you don't write this p and q, they will never ask you anything. Okay, please don't mind if you have not written p and q, don't worry, you go on solving the problem. Okay. So dou z by dou y is f dash of x square plus y square into differentiation of y square is 2y. So now what you can do? Can't we divide equation 2 and 3 easily so that it will get cancelled here? Yes. So divide equation 2 and 3. So when I do that, I'll get p by q is equal to, this will get cancelled, even 2 will get cancelled, x by y. Or py is equal to qx, or py minus qx is equal to 0 is my required PDE. That's it. So is there any difficulty in understanding these type of problems here, my dear students? No. Only thing is be careful with the differentiation. If your differentiation is proper, most of the time that elimination part students will do. Somehow they will do it. Hook or crook, they will eliminate it. But many students will do mistakes in the differentiations. Okay. So please be careful with the differentiation. Next problem. Z is equal to y square plus 2 into f of 1 by x plus log y. Again it is involving only how many function? One function. So one single differentiation is more than enough. I mean no need to go for dou square z by dou x square and all. Those type of problems will be coming next. I'll explain, don't worry. So first I'll differentiate with respect to x and y. So when I differentiate with respect to x, so dou z by dou x, notation is p. Y square, is there any x here? So no. So it is 0 plus 2 into differentiation of f is f dash of whatever is there inside the bracket, you write it as it is, into differentiate with respect to x. So differentiation of 1 by x is minus 1 by x square. Proper? So differentiation of 1 by x is minus 1 by x square. Or I am writing it as p into x square is equal to this minus sign I am taking outside. So minus 2 f dash of 1 by x plus log 1 log y. Okay. Similar way I will differentiate with respect to y. So dou z by dou y is equal to q, or that is equal to 2y. Differentiation of y square is 2y plus 2 into differentiation of f is f dash of 1 by x plus log y, and differentiation of log y is 1 by y. See my dear students, I am telling you again and again, practice the differentiation properly first. If you are very thorough with your differentiation, then somehow easily we can eliminate. Now what I can do, I will first take this 2y to other side. I am writing it as q minus 2y, and then I will multiply with y. So I can write it as here q minus 2y, and this y I am taking to other side. So q minus 2y into y is equal to 2f of 1 by x plus log x. Now what you can do with equation 2 and 3? So we'll just divide this so that 2 into f dash will get cancelled. So what is remaining now is px divided by q minus 2y into y is equal to, minus sign is there, so minus 1 will remain. Or simplify it. So px square is equal to, if I take this term to other side, it will be minus qy plus 2y square. I have multiplied term wise also. Or I'll get px square plus qy is equal to 2y square, which is a required PDE. That's it. Okay, whether you equate it to 0 or whether you keep something in the other side, no one will ask you. I am telling you again and again, if you differentiate, if you eliminate the function, that is more than enough. So I have another problem over here. This is one of the important problem. Okay, there is no clarity over in this problem, so just write it once again by yourself. Z is equal to e power ax plus by into f of ax minus by. So I will differentiate with respect to x first. So dou z by dou x is equal to, I am giving the notation as p is equal to, see here, x is there here as well as here. Am I right? So what I have to do, it's a product of two functions, so I have to go for product rule. So I have kept e power ax plus by as it is. Differentiation of f is f dash of ax minus by into differentiation of ax is a plus f of ax minus by I have kept as it is, that is second function as it is. I am differentiating my first function. So when I differentiate that, differentiation of e power x is e power x only, so e power ax plus by, and differentiation of ax is a. Proper? Are you clear with the differentiation? If you want, you can check here. U as it is, I differentiated v, u into v dash plus v as it is into u dash, so v into u dash. Okay, it's like product rule. Okay, then I have taken one simplification step here. What is this e power ax plus by into f of ax minus by? Is it not the given question? Just check here. E power ax plus by into f of ax minus by is simply z. Am I right? So just write it as z. Okay, so that's why I said to you this problem is very important. Clear? Now I will differentiate with respect to q or with respect to y. So dou z by dou y, which is equal to q. Again I have to go for product rule here because y is there in two terms. So first I will keep e power ax plus by as it is into differentiation of f is f dash of ax minus by, and differentiation of minus by is minus b. Proper? Plus function of x a minus xy as it is, and differentiation of e power ax plus by is e power ax plus by into differentiation of by is b. Clear? Again I can call this as what? Z. I am doing that. So q is equal to minus b e power ax plus by into f dash of ax minus by plus b into this entire term. I am calling it as what? Z. Okay. Now what I can do with equation 2 and 3? How will you eliminate function? See, they are telling you to eliminate arbitrary function. You no need to worry about a and b. You have to concentrate only on your function f. Okay, let that a and b be remaining as it is. So what I can do? Can I divide these equations directly? No. Be careful. If you want to divide it, First take this az to other side in equation 2, take bz to other side in equation 3. Then if I divide, this f dash will get cancelled. Okay. See, that's what I have done here, or in a simple way, I have multiplied 2 by b, equation 2 by b, and multiplied equation 3 by a, so that I will balance this equation here. So when I do that, this entire terms will get cancelled, and what is remaining is only 2abz. So bp plus aq is equal to 2abz. Okay. Or another way of doing it is just take this plus az to other side here, take this plus bz to other side here, and divide it. Okay, you'll get the same answer. Anyway is fine, that is left to you. Or this is one more way of doing. Multiply 2 by equation b, because I want b here, and multiply 3 by equation a. Okay, so that then if you add it, easily will get it as 2abz. Okay, so this plus 1abz plus 1abz will give me 2abz. This entire term will get cancelled when you add it, and only 2abz will remain. That is my required PDE. Okay, one more problem over here. Just check now. Till the previous problems, I had how many functions? I had only one function. But here, how many functions I am having? Two functions. One is f of y and one more is phi of x plus y. Correct? So we'll see how to do it. So first I'll differentiate with respect to x. So dou z by dou x is nothing but, I don't have x here in the first function, so it will be phi dash of x plus y. Now I'll differentiate with respect to z, with respect to y. So dou z by dou y is equal to f of y is f dash of y, and phi of x plus y is phi dash of x plus y. Okay. Then see, only with these two equations, dou z by dou x and dou z by dou y, can you eliminate directly? Not possible at all, because I have two different functions over here. So as I said, here we need to go for second order differentiation. So dou square z by dou x square means if you differentiate this again, I'll get dou square z by dou x square. So differentiation of phi dash is phi double dash. See here, I have not given the notations. That's what I said to you, that p, q, r and all. No, even if you don't write, no problem, no one will ask you. Okay, so that I'll get phi double dash of x plus y. So now what to do? See, I didn't know that I'll get phi double dash here, but I did. You go on differentiating. Okay, next I'll do dou square z by dou y square. So I'll get phi double dash of x plus y plus f double dash of y. What to do now? See, somehow I need to eliminate this, correct? So I cannot do anything with these equations now. So what I'll do is, I have done all possible way of differentiating. Is it so? I did dou z by dou x, I did dou z by dou y, I did dou square z by dou x square, I did dou square z by dou y square. Even after doing all these four derivatives, I cannot eliminate the constant. So what I'll do, there is one more option. If you know, I can go for dou square z by dou x dou y, or dou square z by dou y dou x. Correct? So what I am doing is, I am differentiating this equation 1 partially with respect to x. So what will I get when I do with respect to x here? I will get dou square z by dou x dou y. That's what I was speaking about. So dou square z by dou x dou y is equal to, what does it indicate? I have to differentiate this equation with only with respect to x. So if you check here in the second function f dash of y, I don't have any x there, so it is 0. X is here, so differentiation of phi dash is phi double dash of x plus y into differentiation of x is 1. I have not written it. Now can I think of something? Yes. What is phi double dash of x plus y? That is simply dou square z by dou x square. So I can write this as dou square z by dou x dou y is equal to, in the place of phi double dash of x plus y, I am taking dou square z by dou x square plus 0. Or that is simply dou square z by dou x dou y minus dou square z by dou x square is equal to 0. That's it. Okay, so be careful whenever we have two different functions. No, normally we need to go for all these differentiations: dou z by dou x, dou z by dou y, dou square z by dou x square, dou square z by dou y square, and also dou x dou y. Okay, then you see what combinations we can do. Okay, it's just like a trial and error we have to do. It's not like a specific problem, specific method. Okay, So now I'll go with the one more problem. Z is equal to f of x plus y plus g of y plus 2x. This is bit complicated one. Seeing the question we can tell that. So first I'll differentiate with respect to x. So dou z by dou x is equal to f is f dash of y plus x plus g dash of y plus 2x, and differentiation of 2x is 2. I have written that 2 over here. Okay. Now I'll differentiate with respect to y. So dou z by dou y dash of is equal to f dash of y plus x plus g dash of y plus 2x, and differentiation of y is 1. No need to worry. Can I eliminate these functions directly with these two, with p and q? Not possible at all. So next what I'll do, I'll go for dou square z by dou x square. So differentiate this with respect to x again. So f double dash of y plus x plus g double dash of y plus 2x, and again differentiation of 2x is 2. Already one 2 is there over here, so 2 into 2 will give me 4. Okay. Next I'll go for dou square z by dou x dou y. Let me see. However, all the differentiations are required, correct? So dou square z by dou x dou y. Which one will you differentiate? You have to differentiate this q with respect to x. Okay, differentiate q with respect to x. So f dash is f double dash, g dash is g double dash with respect to x. So differentiation of 2x is 2. Now I'll go for the last one, dou square z by dou y square. Differentiation of f dash is f double dash, and g dash is g double dash. Okay. Now tell me what I can do. All the 5 types of differentiations I have done. I'll number the equations 1, 2, 3, because however dou z by dou x and dou z by dou y will never help me in any of these combinations. So just will call 1, 2 and 3. Okay, now my question is, what combinations you can do so that we can eliminate the functions. So check properly here. So if you check my equation 1, it is f double dash plus 4 times g double dash. If you check my equation 2, f double dash plus 2 times g double dash. And if you check my equation 3, f double dash plus g double dash. So 4, 2 and 1 are involved in g. So what I can do now? So first what I'll do now is, I'll subtract 1 and 2, because 4 minus 2 will give me 2. Am I right? Correct? So r minus s is equal to, see this f double dash, however it will get cancelled. 4 minus 2 is 2. 2 into g double dash of y plus 2x. So what happened here? My f double dash got cancelled. Am I right? Yes. Now what I can do? So then I'll subtract 2 and 3. So when I do that, what will happen? 2 minus 3 or s minus t is equal to, again f double dash will get cancelled. 2 minus 1, that is 1 times g double dash of y plus 2x. Now what I can do? Can't I multiply this equation 5 with 2 so that the equation will be balanced here? Yes. So then I can divide it. So just check here. Okay, I have directly divided. So divide equation 4 by 5. So r minus s divided by s minus t is equal to, when I divide this, g double dash will get cancelled, equal to 2 will remain, or r minus s is equal to 2 times s minus t, or r minus 3s plus 2t is equal to 0. Then replace back what is rs and t, that is the required PDE. Hope you are clear with this problem. So I'll tell again and again, whenever you have two functions, no, f and g, it is always better you differentiate all the 5 terms which are possible. That is dou z by dou x, dou z by dou y, dou square z by dou x square, dou square z by dou y square, and dou square z by dou x dou y. And obviously this dou z by dou x and dou z by dou y will never help you to eliminate these functions. Only possibilities are this r, s and t. So only with these 3 equations you have to do some permutation combination, and you have to eliminate the constants. So here what did I do? First I subtracted 1 and 2, then I subtracted 2 and 3. I'll get equations 4 and 5. Then you just divide equation 4 with equation 5. That's it. That will be the easiest way to do it. Okay. So this is all about eliminating the arbitrary constants and arbitrary functions. So again, in this eliminations, if you have any doubt or any confusions, please contact me. And I'll remember one thing, if you know the differentiation properly with any of the trial and error method, you can eliminate the constants very easily. Okay, it's not at all difficult to eliminate the constants or eliminate the functions, but only thing is you have to know how to differentiate the function given equation. Okay, so this is all about eliminating arbitrary constant and arbitrary functions to form a PDE. Okay, so if you have any doubts or any confusions in this, please contact me. Thank you.